Testing. Testing, testing. We're talking about testing. Testing. Is this working? I think it is. This fucking screen isn't aligned. There we go. Alrighty. Let's make sure that this is working. Does not look like it's working. 1 second, let me restart the viewer here. So I'm using a VNC, which is basically a way to get Linux to stream a screen into a Windows, because I have OBS running on a Windows computer, and then I have this Linux computer using VNC to stream to the Windows computer. I think I need to do this. This is kind of a fragile setup for any of you guys that are kind of into this streaming. Maybe I can do a stream where I talk about my setup. Oh my God, come on. What is going on here? Connection closed unexpectedly. I guess we gotta reopen that. Oh no. Oh no. If we can't get this to work, what are we gonna do? All right, so we're on this port. This is usually the port that is open for these remote streams, by the way. So if you're trying to create some hacking scripts, you should always try to brute force in this port, because generally people don't have a ton of performance on that. I think I need to properties. 5091. There we go. Alrighty, we got this going. Let's switch over. You got to make sure to allow remote control of your desktop, you know. Why does this still not fucking work? Holy shit. Ugh. Hello, everybody. Is this a VM Ubuntu that you're running? No, this is a actual computer with Ubuntu on it. Sudo basically, I have my streaming set up on my Windows computer, and then I'm using a VNC, which is basically a remote desktop software to get the Windows computer to be able to see my Linux computer. Right, but the way that it's working right now, I'm trying to see if I can find this Vino server. Sudo pkill Vino server. Of course, I get my password wrong 10 times in a row. Fuck. Get that. All right. That's killed. Let's restart this. Okay, let's switch over. run that. Desktop sharing message service is already running. Okay, run it again. It's on port 5901. Switch over. Let's get this to port 5901. Okay, I'm gonna make sure to hit OK there. All right, did that work? Come here in OBS Studio. Looks like it's working, right? So I'm looking at my OBS Studio. It looks like it's Bard is up. And if I switch over here, no, just not update. Okay, it does update. It's just kind of slow. We'll see. We'll see if this works. Okay, that's much faster. I think we're finally going. I think it's live. All right, we got our Linux system. Alrighty. I think some of you guys were asking about my system. So I've been using Ubuntu for a very long time, back since I think actually 12 was the first one that I used. This one is now what version is this? I'm going to see which version is this. I think you can do keyboard about right here. So this is what this is currently. This is Ubuntu 22. So whenever you see Ubuntu version, the little LTS at the end of that means long-term support. So basically you just want to jump from long-term version to long-term version to long-term version. So I think 12 and then 18, I think, or 16, and then 20, and then I think 22 is the next long-term version. So yeah, I recommend Linux. It's very great. It generally always works well for any type of kind of programming that you want to do, right? Like NVIDIA GPUs always work well. Any kind of robotic things work well. Docker works well, right? All the different pieces that you want work very well, versus getting all of those to work on Windows is a huge pain. In fact, the way that you get it to work on Windows is by doing a Windows subsystem for Linux. But I've tried both of those. I've tried WSL1, and it was a huge piece of shit. Just constantly crashed my computer. And then I went back to Linux. And then when WSL2 came out, I also tried that, and that was also a huge piece of shit. So, and then of course, like usually in my jobs that I've had, whenever you join a startup, generally you're using a Mac. But I don't know, I've never been much of a Mac fanboy, even though most of my friends who are more legit at computer science, they generally tend to use Macs. But I don't know, I just like Ubuntu. Cool. So this is where we're at right now. We're pulled up here. We have basically a little Discord bot that we were working on last week, and I haven't really done a ton of changes, to be honest. So we're mostly just going to be continuing on the thread that we were doing. I have Bard and ChatGPT pulled up so we can ask it some questions. Let's go on the actual stream here. Hello, Tengda. And we're going to go into this bot debug channel. And this bot debug channel, I am falling in love with Ubuntu, Mac terminals, and a system as a whole. They're pretty similar to each other. Yeah, they're both based on Unix, right? The terminal is the same, basically. Slightly different, but the same. You don't have that terminal in Windows. The Windows terminal is like some weird piece of alien technology. Okay, so let's come here, and I think we have to do, it's called run.py, so let's run this, python run.py. And we should see a paperbot has entered the chat. There we go. Alrighty. Okay, so let's put some breakpoints in here. So the way that we were structuring this project, we basically have a Discord bot, but the Discord bot is kind of like a tool former kind of design pattern where basically we're creating these behaviors, and then the chatbot, or the actual LLM here, of which there's 3 different ones. You can use 3.5 Turbo, GPT-4, and then Palm, which is Google's LLM. We're having it actually pick the behavior to use. So whenever you actually send a message to the bot will pick which message or which type of behavior to run. So let's come here and we'll actually put a little breakpoint there. And actually we need to kill it here because we need to run it from this VS Code like this in order for the breakpoint to be active, right? All right, so Paperbot has entered the chat. Now let's say at Paperbot, and we'll say, how are you doing? All right, so we hit the breakpoint. So the message that we received from Discord should just be at Paperbot, how are you doing? Okay. Then we're giving, in this case, I think we're using GPT 3.5 as the default LLM, but we're giving it this prompt here. We're giving it I am, which I defined here at the very top. It's basically just, you are Paperbot, a helpful bot. You help people organize archive papers. And then the command is determine which behavior the user wants to run. Do not explain, return the name of the behavior only. The available behaviors are, and then previously what we were doing last week is we were basically just giving it a list of function names like add paper, list sources, list author, but sometimes it wasn't really finding the correct behavior. So I added I wrapped the behaviors in this little data class here. Data class is a Python data structure that just makes it very easy to define little these kind of like basically a name tuple. Like previously you would have done this with a name tuple, but now you can just do it with a data class, and it's a nice little convenient typed holder, struct basically. And we're saying, okay, here's the list of behaviors, here's the description for each of the behaviors, and then here's the name of all the behaviors, and then hopefully if we do this, right, it's going to add all the behaviors, and then at some point it's going to send it to GPT. GPT is going to guess the behavior. There we go. So what did the behavior guess? The behavior guess is chat. So you see that? GPT chose chat out of these behaviors based on the prompt, or based on the question that I gave it. Let me make this bigger so you guys can see better. But I gave it a question that says, how are you doing? Right, and then it decided, okay, that's the chat behavior. All right, so we're going to hit next here. Make sure the behavior is not none, running the behavior. Print the message. Send the message, so it sends. Running behavior chat. And then it's actually going to call this behavior function, right? You see here how the behavior is a callable, so basically a function. Hello, everybody. And we're actually giving it a handle to our database object, which is, right now it's not fancy at all. It's literally just a CSV file, but at some point we can replace this with a more fleshed out database. All right, so it ran the behavior, and the bot literally said, Paperbot has entered the chat. Okay, kind of a weird response. Let's see. GPT chat, GPT text, Palm chat. I am response to the user's message. This is the user's message. So one thing that I don't like here, right, is that I have 2 different chat functions. Asynchronous, this is what this async means. It's basically it can run separately from something else, you know? So anytime you have like functions that call external APIs, right? You don't want to just sit there and wait for the external API to give your response back. So you can basically use this async await pattern, and it allows you to kind of do other things in the meantime if you wanted to. But we have two different functions here, one for Palm and one for GPT, and I want to combine these into a single chat function. So we're going to do this. We're going to do async define. We're just going to call it chat. This is going to return a none. Do we want to do like a giant if-else statement? I feel like that's a little gross, right? List author, list sources. Yeah, maybe we don't want to do this. Let me see. I had a list of different things we could do today. I feel like refactoring is not necessarily the most interesting list of things to do. Let's see, this one. Journal. Paperbot. All right, types on the database class, lock on the database class, behavior action data class, prompt editing for reducing total token usage. Actually, you know what? Why don't we do that? That's actually probably a better use of time. So, all right, one thing that I was thinking about is that whenever you're using LLMs to kind of like go through the state machine for you, right? Like, you want to make sure that you don't have a ton of tokens, right? Like, for example, right here, is there a way for us to reduce the amount of tokens here? Choose a behavior from the list below. Do not explain, return. So is there a smaller, more concise version of this right here, right? The do not explain, return the name of the behavior only. What if we don't need that? What if we can just, let's comment this out and see if it works with just this. Let's also go up here to the actual IM, and let's try to make this a little bit. You are name a helpful bot. What if we just say, and this is why I have this pattern. So like some of you that actually program well, you might be saying, why the fuck does he have this like weird list of strings that is then joined by nothing? It's because it makes it very easy to comment and uncomment, so I can modify the prompts quite easily. So let's say, let's make this an F string, and let's say you are Paperbot, a librarian, or a archive chatbot. Okay, so that's, we just reduced the size of this prompt. So, right, so we went from basically whatever this is, 6 tokens. There's one word is not 1 token. It's a little bit more complicated, but you can kind of roughly estimate it like that. We went from basically maybe 12 tokens here to 6 tokens, so that's properly reduced. Then we come down here, we reduce this to also significantly less tokens, right? And let's reduce some of these descriptions here. So we have add paper, list papers, list sources, list all sources for the paper. What the fuck is this? Did we even implement this behavior? No, it's list sources. Provide links for finding papers. List papers is list all papers in the database. Can we just, is DB better than database, or should we say database? Let's try DB. It's less tokens. Add a paper to the DB. List author. Provide. What, instead of provide, what about share? Let's also rename this. So here, if I hit F2 here in VS Code, you can rename the entire thing, and that prevents me from having to basically go through this entire file. So I'm going to rename this to, let's call it share sources. Just so we're not using the same word list. I don't like the word list there because it kind of probably confuses it with some of these other behaviors like list paper and list author. Let's put chat up here. And let's do this. Control H, list sources. Let's replace with share sources. List author. Let's call this author info. Author info is a behavior that we made where it lists, it uses the archive API to find information about the author, and then it lists previous work. So shares previous work for a author. Install papers, add paper, chat with the bot. Okay. I kind of like these behaviors more now. Let's get rid of this function here. Pass. We'll deal with this later. All right, let's see if it's still able to get the correct behavior. So let's kill this. Let's rerun it. Let's come here. Let's put a breakpoint right after the behavior guess. And let's see if we can get it to do the author info behavior. At Paperbot, can you tell me more about is that how you spell Jan LeCun? Gone to my head, I don't actually know how to spell Jan LeCun. I think it's 2 N's on both. No, 2 N's only on the first one. Okay. All right, so the guess behavior is, what did it guess? It guessed, oh, we still have to call this. Okay, it calls it, and then what's the guess? Come on. There it is. It's waiting for the GPT. All right, and GPT guessed. Okay, so you see this is a problem. Is beforehand, we tried it with this extra part here, and it gave us exactly the behavior name. But whenever we got rid of this here, it's just kind of giving us a bunch of crap. It's giving us Jan LeCun. So let's add this part here. Choose a behavior from the list below. Choose a behavior function. What if we just, let's do this. Let's try just adding that and see if it gets at that. So we're kind of doing a little bit of prompt engineering here, to be honest. Code Whisperer is free and found reasonably on par, better than Copilot in some cases. Yeah, we've tried some other coding bots, but in reality, like, the benefit of Copilot is not necessarily that it has the best solutions. The benefit of Copilot is that it's deeply integrated into the IDE, you know? Like, for me, I'm going to continue to use Copilot until someone integrates and makes it easy for me to choose a different code LLM, right? Copilot X, yeah, we were playing with that one too. You're talking about the one that has the little chat window on the side as well. Let's paste this. All right, what is the guess? Let's actually put it down here. Author info. Okay, so there we go. That's actually pretty interesting. So you see how it didn't actually work until we put this, right? If we got rid of this part of the prompt at the beginning, then it would just give us information on Jan LeCun. But by adding this line right here, the do not explain, return the name of the behavior only, we were able to make sure that the behavior guess is author info, which is what we want, right? We want it to give us one of these 5 strings. All right, so let's take this prompt here, the system prompt, and let's go into ChatGPT here. Where is it? Is it here? Or let's go into Bard. Bard is fine. And let's say I am using this prompt to have an LLM select, let's make this bigger so you guys can see, a behavior from a list of function names. Can you reduce the number of tokens in this prompt without impacting the I guess the result? Actually, let's get rid of that. All right, so we're going to give it this prompt here. Let's do this. Let's get rid of this. Choose. Okay. Let's see what Bard has to say in terms of reducing the number of tokens in this prompt. And let's also see what ChatGPT has to say about reducing the number of tokens in this prompt. The prompt is 15 tokens long compared to the original prompt of 21 tokens. This reduction in token count will save you money. Okay. Randomly select a behavior from the list. Return the name of the behavior only. Okay, so it seems like Bard is saying that we don't need this part here, the do not explain, so we can save a little bit of tokens by not having this part. Let's look over here. Select a behavior from the list, return its name only. Okay, so let's try that one. Let's kill this. Let's get rid of this. Let's get rid of this. And let's do this. So let's try this prompt here. See if we can get it. Why don't we get, let's just try it with the IM and then we'll try it without the IM. All right, let's put this here. Let's go into our Discord. Copy that. Paperbot has entered the chat. Let's paste it the same thing. All right, there we go. The behavior guess. No, that didn't work. You see what I'm saying? Look at that. So this prompt did not work. You see how if I hover over behavior guess, what GPT guessed is basically what we were complaining about before, where it just gave us like a phrase of that. Return its name only. Okay, so GPT did not give us a good shortened prompt. Let's try the shortened prompt at Bard. Return the name of the behavior only. Let's try that. Randomly select a behavior from the list. Return the name of the behavior only. It's a little bit more words, but you can see how here maybe the GPT is getting confused by the use of the word "it's" here, right? Like maybe by saying the name of the behavior, maybe that helps it. So let's try that. Let's also get rid of this randomly. I don't actually want it to select a random one. All right, let's kill that. Let's run it. Paperbot has entered the chat. Let's copy this. Let's paste it. What you doing? Code Whisperer is integrated into a bunch of IDEs. The strong context awareness, snippet insertion. Paperbot has entered the chat. Come on. Come on. Sometimes the API, OpenAI API takes forever. All right, let's kill it. Let's rerun it. Paperbot has entered the chat. Tell me more about Jan LeCun. Let's turn this into a log.info just so we can actually see what the fuck is going on here. Log.info. Why'd this no work? Let's kill it. Save. Go back. Rerun. Copy the message. Enter the chat. Paste the message. Receive the message, so it's getting to it. It's just not... We're just DDoSing the OpenAI API is basically the problem. We actually go to OpenAI API. Log in. API. Do we have like a account somewhere where I can see what the actual calls are, like a log? Examples? Nope. Overview? Nope. Account? Usage? Here we go. Boom. This is what I want. Daily usage. Well, that's fucking worthless. Like, I want individual things here. Ugh. All right, so GPT is dead. So we're going to have to do this with Palm. I think if we actually go to this GPT text function, it takes a prompt, a system, a model. What does the Palm one look like? Define text, Palm text. You give it a prompt. System. Let's do this. Let's modify this GPT, or GPT text has this specific format here. Let's do the same thing with this Palm text. So we can basically make the Palm text and the GPT text have the same exact kind of quargs and args, so we can basically interchangeably use these. So let's do a prompt, which is going to be a string. Then we're going to need a system, which is also going to be a string, and this is going to default to none. Code Whisperer. Why not use LangChain to interact with LLM? So I have messed with LangChain. I think we did a stream beforehand where we used it. But here's the problem, is that LangChain, I don't think it's going to stick around. I think realistically, any of the services that offer LLMs like GPT or Google will consume whatever LangChain is doing. So if you start using LangChain, all you're going to be doing is you're going to be learning all these abstractions that the people who wrote LangChain created. And those abstractions aren't actually abstractions that matter. You know, like realistically, if you want to get better at LLMs, you need to be interacting with the LLMs yourself, right? You need to start understanding the difference between using lots of tokens, not using tokens, how to use the system prompt, how to not use the system prompt. Like anytime you use a system like LangChain, right, you're using abstractions and you're not actually learning what's underneath. And for example, like there's people who know, or maybe they learned a bunch of cloud abstractions for AWS, right? And it's useful because they can use AWS and set up a system, but then the second they move to GCP or another cloud provider, they don't actually know what's underneath those abstractions, and they just know the systems in AWS. So for me, at least when I'm playing with a new technology like LLMs, I don't want to just learn some abstractions that some random dude created in LangChain, right? Because in fact, those might not even be good abstractions. Maybe they're bad abstractions. So the purpose of this Discord bot is not to create the best possible Discord bot. The purpose of me making this Discord bot is to just kind of become more comfortable with LLMs and kind of understand deeply kind of how you would actually design a system that uses LLMs to do things like choosing which behavior to call, right? I don't know. That's my convoluted answer as to why I'm not just using LangChain. Okay, so we got the model, and then here we're going to say if system is not none, then the prompt is going to be this. It's going to be the system and then the prompt. Then here, the temperature, we actually need to pass this. So let's say temperature float equals temperature. And let's also say maxed tokens. So we can get rid of these two here. Okay, let's get rid of this comment because we don't need it. Do you think a better open source alternative will come? Yes. That was my that was what I came out of that stream. I did a stream where I looked at LangChain and it was just not, it was not good. You know what I'm saying? Like it's just kind of like gross. Like they have so many abstractions. Like look at this. They have models, memory index, chains, like this whole concept of all this crap. And I think a better example of this is if you do the you go on Twitter LangChain. They were advertising some stuff on here. But yeah, this stuff here. So for example, look at this Twitter thread here. They're like, we built a thing in 10 lines of code or whatever. And then you actually look at the 10 lines of code. Look at all these abstractions. You have a document abstraction. You have an API FI wrapper abstraction. You have a vector store index creator abstraction. You have a chat OpenAI abstraction. Dot call actor, like actor ID, run input, dataset mapping function. Like, you know, what's the point of learning all these abstractions, right? The fact that you have to do this call actor and then pass a Lambda function that returns a type of document that requires these specific things, like, to me, this is fucking worthless, right? Like, as soon as someone creates a different set of tools that have a different set of abstractions, all the time that you put and all the capacity in your brain that you used to store basically these abstractions is now worthless. So I don't want to just learn. If you have a limited amount of time, let's say you're at a startup and you need to basically create an LLM app, and you need to have that next week. At that point, then yes, use LangChain, because it'll allow you to create more things faster, and those things will be of higher quality. But if you're not in the business of creating a product and you're in the business of learning, right, and you're just trying to learn, this is not going to teach you the right things. There might be all kinds of mistakes in here in terms of the abstractions, right? So, like, even this shit here, like, look at this. The LLM, line number 19 here, LLM equals chat OpenAI. This isn't even an instance of the class chat OpenAI. This is literally the class itself. They're monkey patching the class name with this lowercase LLM and then passing that to a query with sources, which I don't know what that does, right? Yeah. I've just fallen into this pit before. It's like, if you guys are in the robotics world, another one is, for example, ROS. Like, you know, think about how much time you spend learning ROS, and then it might turn out that actually, if you want to work on humanoid robots, they don't even use ROS anymore. So then you have all these abstractions that are ROS based in your head, and none of those necessarily help you. They might even hurt you, because those abstractions are the result of specific constraints and design requirements that might not even apply anymore, right? So, I don't know. I think you have to be careful about just filling your brain and learning like specific abstractions behind specific tools, because tools don't last very long. Tools very quickly change. So to me, it's like understand and learn about the fundamental technology itself, which is LLMs, and try to build just simple systems like this little bullshit little Discord bot that we're building here. Try to build a simple system where you actually make all the abstractions yourself. You decide what the abstraction is, right? You sit there and think about, okay, what should this behavior data class be? Should it have a name and a description? Should I have tags here? Like, what do I need to do here, right? Like, and the process of having to come up with your own kind of simple abstractions in order to do a simple little MVP, I just feel like that's going to be more useful than just sitting there and reading the LangChain documentation and just kind of like taking all these abstractions for granted and just not really thinking about why they created those abstractions or why they shouldn't have created those abstractions. All right, I'll get off my soapbox, but that's why I'm doing these things from scratch. Okay, so we were basically going to use our Palm chat instead of GPT chat here. So let's try that. This is for sure going to error out, so let's see where it errors out. Paperbot has entered the chat. Okay. Received message. Okay, so you see the problem here is it's saying received message, but we're not getting a mentioned in message. So it's not getting past this line right here. So I think the problem is it's not actually, it doesn't think it's actually getting called. So let's do Paperbot. There we go. Okay, so there's a difference between if you copy paste at Paperbot versus type it out, it seems to result in a different behavior in the Discord, which is kind of important to think about. Okay, so behavior guess, Palm chat. Let's step through this. It's probably not going to work. Okay, Palm chat got an unexpected keyword argument prompt. Okay, so you see here the problem is that prompt here is defined as a kwarg or a keyword argument, but here we defined it as a, also it shouldn't be Palm chat, it should be Palm text. But in Palm text, right here, this needs to be a kwarg, so let's do this. If system or if prompt is none, I think when we might still need an abstraction layer, as different LLMs will have different ways of interacting. Think of when you plan to use multiple LLMs to get results. Exactly. I agree with you, Work, right? I'm agreeing with you that and there's nothing like this is more kind of just my opinion, right? And like I said, the situation is going to change, right? The benefit of abstractions is that you can start from a place that's further along, right? So the benefit of using ROS, the robot operating system, is that it comes with all these abstractions that other people thought about. So you don't have to think about those. And if you really need to build a product or build a little MVP as quickly as possible, building on top of somebody else's abstractions is the fastest way to do that. But the problem is that then you never actually really learned the reason why those abstractions were chosen, or why those abstractions exist and not different abstractions exist, so that in a sense you're not actually understanding the underlying technology. You're just kind of memorizing the abstractions that somebody else created for you. So as soon as those abstractions change, maybe because the original abstractions didn't account for compute, or maybe they didn't account for asynchronous kind of behaviors, right? Like, there's all kinds of design requirements that could suddenly become much more important, and at that point, the abstractions don't work anymore. And then if you just learn those abstractions, it's not gonna be a good time. So I think it depends on what you're doing. If you're working at a startup and you need to do something as quickly as possible, definitely use LangChain. But I'm not in that situation, right? So yeah. That's what I'm saying. To me, it's like, could I write this entire chatbot in like 10 lines of code with LangChain? Yes. Do I want to know? Do I want to like do that? No. I'm doing this for the purpose of that, right? It's like I want to really fundamentally understand how toggling between Palm Chat and GPT Chat is. And then I want to do that enough times that in my head, I'm like, hey, I kind of want a way to toggle between these Palm Chat and GPT Chat that doesn't involve two separate functions. How should I do that? Should I make a single function with kind of if-else control logic that like goes into a specific one? Should I create some kind of generic function that then maybe like calls other things? Should I have an LLM that chooses which one to call? Like, and forcing myself to think about those things will make me more familiar with the actual design choices that are going to lead to the abstractions. I'm glad you guys agree with me on the abstractions. Okay, so we're here. We learned that you actually have to, you do have to type it in. So we do have to type in @paperbot. Nope, not @Pradeep, @paperbot. All right, let's see if Palm Chat works now. Oh my God, because it's not Palm Chat, it's Palm Text. You see that? And now I'm learning in my head, okay, well, text and chat are very similar kind of words. Maybe I should come up with a better name for the raw function versus the chat function. Let's run that. All right, so it is calling. There you go. It's calling Google API. Request had insufficient authentication scope. I think we ran into this before, so maybe let's go. Let's run back. Let's run back to GPT. Okay. @paperbot. Can you tell me more about Jan LeCun? Mentioned in message, behavior equals. Fuck. You say no, it didn't choose a behavior. So it just seems like both of these shortened versions of the prompt that GPT and Bard gave us are not good. So let's go back to the original one like this, the one that we knew worked. So let's confirm that this one works again. So we're trying the prompt that we designed, which kind of puts it in Toolformer at paperbot, and then tell me more about Jan LeCun. What did it choose? Author info. Okay, so this is correct. What if we get rid of the IM? Right? Maybe we don't need that. Let's see if it still works. Yeah, it still works fine. Okay, so we don't need this IM at all. All right, nice. Okay, so we've reduced the prompt that we use to select the behavior. We've reduced the total amount of tokens, and because this system prompt gets called every single time we do anything in this with this chatbot, it has to pick one of these 5 behaviors. So making this prompt as short as possible is important. So we've managed to reduce the size of this prompt. Let's actually go ahead, save that, Control-Shift-G to open up the thing and say better behavior prompt. We'll add this little plus, we'll commit that. So make sure to commit often and frequently in case your computer explodes and shuts off. So I don't think that's necessarily as much of a issue anymore, but you know, sometimes it is. Okay, so we get our behavior, then we call the behavior function right here, and we're calling it with the DB. Okay, so let's see if the thing works well without the breakpoint. Running behavior author info. Okay, it's using the author info behavior. Await behavior. Behavior object is not callable. Okay, so right here we're getting a behavior object, right? But we don't want to call the actual behavior. We want to call the behavior.func. So this is the actual callable here. Let's do that. Running behavior author info. Okay, it's calling the archive API. Okay, first page, 127 results. Obviously, Jan LeCun has a ton of papers, and then here you go. Here are other papers by author Jan LeCun. There we go. We got a little bit more stuff. Nice. Alrighty, look at that. Okay. So we can close out of that. Let's save. Let's work on some of these other behaviors. Author info, share sources, add paper, list paper. So one thing I wanted to do is I wanted to have the name of the people who suggested the paper. So in my little random database class, this local DB class that I have ID, which is the ID of the paper. We have the title, we have the URL, we have the authors, we have the published date, we have the abstract, we have the tags of the paper, which I think are actually, we don't even need that, right? I think the archive result actually gives you categories, yeah. So let's run that there. Tags equals GPT tags. Create a separated comma list of tags. This is what we were doing before. We were using GPT to do that, but that's just a bunch of extra calls. So let's just go ahead and do that. Let's do paper.tags. Let's see what Copilot. There you go. Tag.term. I don't know about this tag.term crap here. tags or categories here is a list of strings. So really this is actually incorrect. What we want is this dot join, and then we're going to have the list of strings, which is paper dot categories. And we don't actually even necessarily need this to be its own local variable. We can just actually define it directly inside the data frame there. Data frame, and then we also wanted the suggester here. So this is the field that we want to add. So let's do this. Let's add suggester. And there's no way around having to pass that in. So I think we need to pass in the suggester. This is going to be a string. Let's make that a quarg. So it's none, and then we can make sure that we can account for the fact that sometimes it's going to be none. So we can say suggester or something like that. So the way that Python works, basically, if suggester is none, it'll use this instead. If suggester is a valid string, it'll just use that. So basically, this is the default suggester. All right. Save, that means that this function call here, add paper, we need to pass it some additional parameters. So one thing you noticed here is that all of our behaviors have, right now they have the same method signature, I guess. I don't know if that's the right Python term but basically they have the same arguments here. But the problem is that we're gonna start to have custom arguments for custom behavior. So what we're going to do is we're going to do that. We're going to do star star quargs, and then here we're going to do suggester. So why are we doing this? The reason we're doing this star star quarg is so that whenever we come here, right, we can pass it a bunch of crap. We can pass like blah, 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 like a bunch of crap like this, and whether or not this behavior uses that crap or it doesn't use that crap, that's totally fine, right? So let's say suggester equals, and then here self.user_id, I think we want message.author.name, so this part right here. And let's actually get rid of this suggester. Let's control H everything for suggester. Let's call it human. Human? What's a better name? I don't like the word or the name suggester. User, I think, is a better name, but user is a little bit more confusing. Let's just say user. All right. So there we go. All right. Add paper, and also while we're doing that, let's also add the star star quargs to all these other functions here. Chump. User is fine too, I guess. Okay, I thought you were calling me a chump, and I'm like, damn, oh no, shots fired. List papers, share sources. We'll add these star star quarks just so like these functions can take a bunch of extra crap if you pass it a bunch of extra crap. Let's make these consistent here. Star star quarg, and let's make our chat function that we were talking about, right? Let's call it def chat. Let's do this. Let's copy that. Let's put that there. This returns a none. I think pretty much all our behaviors return none. That's not necessarily great, actually. Ideally, you want to basically get whatever this returns, this send here. Asynchronous define send. This returns a message. So we should be checking this message, whether or not it's basically none or not, and then that kind of gives you a way to basically check to make sure that the message was this await actually performed successfully. You know, generally you don't want to return none. You want to basically return, hey, did this actually even run? So let's open this. Let's put that there. Here we're gonna have a couple extra cores here. We're gonna have temperature. We're gonna have not top P. We're gonna have max tokens, and let's say temperature here and max tokens, and response equals this. Let's do that. And let's have let's use if statements. I know this is a little bit gross, but let's do it. Let's do LLM is a string, and this is going to be the let's call this default LLM. And let's actually change this right here. Let's rename this to default temperature. And let's rename this to default max tokens. And we're going to go up here, and wherever we define that, default max tokens, default temperature, let's also make a default LLM. And let's set this to GPT 3.5. Let's have some types on these globally scoped. Variables here, this is going to be a float, and this is going to be an int. All right. Let's go back to our GPT text. That seems fine. I think here it's called model. Whatever, we'll leave it at that. Local DB, add paper, list paper, share sources, author info, LLM string, default LLM, if LLM equals or dot contains or starts with GPT, then let's say LLM, let's make a little local variable here called LLM func, and this is going to be none, and this is going to be a callable. If our LLM, which is a string, then that's what we want to use. We want to use the GPT text callable. If the LLM starts with Palm, so close out of that. Then we want our LLM func to be Palm text. And then we can, because both Palm text and GPT text, both of these functions have the same arguments, we can basically just do this. LLM func prompt system. I think we can do this, right? That's a little bit cleaner. Or actually, wait, we are going to need the comma there because we're going to have to add temperature and max tokens. All right, perfect. And we can get rid of Palm chat and GPT chat. We can get rid of these functions here now. Perfect. And that means that we can go back to our behavior list here and just call chat. Okay, so another thing we're going to do here is we're going to have to delete our database. So this is our database. Let's delete that. little CSV file, so we're going to create a new one. And we have a default LLM. We have max response tokens. Let's rename this. Let's just call this max tokens. And let's also have a temperature here. And let's set these to the defaults that we had at the top there. Default temperature, default max tokens, and default LLM. Let's set it to that, default LLM. And we'll do this. Make sure that our properties are correct. There we go. Do we need this assert here? I think we can actually move that to the actual chat behavior. So if we actually go to the chat behavior, I think we can put this assert statement here. Assert that the LLM is inside this list of LLMs. Generally, you don't want assert statements in like production code, but this is not production code, so. All right. So we have the chat. We're now passing the user that sends it. We also need to pass in the temperature, self.temperature, max tokens, and LLM. So you see all these extra quargs getting passed in. Another way you could do this is you could have a config object and then you could pass in a config object. That's another popular pattern, right? You could basically imagine something like this. Config equals self.config. And then you could basically make all of these inside a config object. Like. Do I say the word like a lot? Maybe. I feel like most people that learn American English say like a lot, and literally. Okay, let's see if this even runs. Okay, Paperbot has entered the chat. Let's copy a random link from one of you guys here. Let's copy this paper, and let's see if we can get it to at Paperbot. Just give it that link of that archive paper. It's running the behavior add paper. It added the paper 2306.01567. Seems like it worked. Okay, so now let's do at Paperbot. What papers do you know about? Could not find behavior. I'm sorry, but I'm not capable of storing information about papers. Okay, well, at least it tried. Let's try at Paperbot. Can you list the papers? Running behavior list papers. And there you go. There's the one paper that we added. Okay, nice. So unfortunately, the way that we did this, what the hell is this cs.cv? I think that's the category. So I think we replace tags with the category, but really what we want is the summary. Summarize paper. This is the one that we want. Let's do this. Summarize this abstract in one sentence. Do not explain. Only provide the one sentence summary. Here is the abstract of the paper. Okay, where does this get used? This should get used every time you add a paper. Discord.embed summarize paper of result. Okay, so this only gets called on author info. I think what we really want is we want this summarized paper to be called whenever you actually add a paper to the database. So let's go back to our database. Whenever you add a paper, there's an abstract. Let's also add a summary. Look at that. I didn't even have to I didn't even have to do anything. It just automatically knew that I wanted to add the summary. That's some Copilot omniscience right there. And let's add the summary there. And the summary is going to be, oh my God, summary, summarize paper of paper. Perfect. Okay, and then whenever we actually list the papers, yield from self.df iter rows. Where does this get called? For paperdict and db.list papers, embed here, and I think this is the description. So now we want to do the paperdict and we want to do the summary. All right, so let's close out of that. And because we fucked with the database, right? Whenever we added this extra column here, the summary column, normally in a production system, you'd have to do what's called a migration, where you basically have to change the entire database. But this is how we do a migration in our database. We just delete this file. There you go. No migration needed. All right, so let's run this. Paperbot should be coming online. Paperbot has entered the chat. At Paperbot, let's give it this name of this paper again. Oh my God, can I like copy this? There we go. Running behavior, add paper, that's the correct behavior. Okay, I think it worked. Let's now do at Paperbot, list the papers. Running behavior, list papers, that's correct. Bad request, cannot send an empty message. Okay, so where did this fail? In list papers, line 297, so let's click there. So something happened here. For db.list papers, channel.send, listing the papers. So let's do this pattern that we were doing before, where we do, you see it got here. Listing the papers, listing the papers. Let's make a string. And let's say listing blank papers. Listing papers, and then we'll say in parentheses, however many total. There you go. What's wrong with this? There's an extra bracket there. And then we'll log.info this message, and then we'll also send this message. Actually, I don't think we need to send the message. Okay, let's do that. So I think the reason it failed is because it got an empty message somehow. So let's kill this. Let's rerun it. And it should still be there. It should have loaded the, because it saves it to file, so the database is persistent. List papers. Running behavior, list papers. And it errored out. Did we at least get one? 0 total papers. Okay, so it didn't add the paper. That's the problem. There's no papers. So let's see if we can get it to add a paper. Add Paperbot. That's not what we want. We want this one. Running behavior, add paper. Did that work? Found paper, unable to VStack, column names don't match, summary and tags. Okay. You see that? It's a very standard problem with databases where summary, you see how this is flipped, so it needs to be like this. Let's make sure we have all of these. If you go in VS Code and you actually multi-cursor like this, right? You can compare. Is that the same? So if I hover over this, title, URL, authors, published, abstract, summary, tags, user. Okay. I think that's correct. Let's kill it. Let's rerun it. Let's come back. Add paperbot. Add this paper. Okay, running the behavior add paper. It added the paper. Perfect. And now we say at paperbot list papers, running behavior list papers, and then there you go. Boom, you get the name of the paper with a little link so you can click on it and you have the actual PDF. And then it gives you the one sentence summary by GPT, and the one sentence summary is created from the abstract. So there you go. Is a model that accurately segments an object while maintaining the original promptable design, efficiency, and zero-shot generability of the segment anything model. Pretty cool. Let's add another paper. Let's go into the papers. Let's go up here. What about this one? Brain Former. Let's copy that. Let's go into our debug. Say at paperbot. And because we're using an LLM to pick what behavior to do, we can actually be quite vague about it, right? So we can actually have a weird command. Check out this cool new paper I found. And let's actually mess up with this. Let's do archive.org, and then let's also do actually, no, let's not do that. Check out this cool new paper I found. Paperbot saying running behavior add paper. Okay. Adding paper. And now if we say at paperbot list papers. Running behavior list papers. Boom. There you go. Look at that. That's pretty cool. It's starting to look pretty good. All right, let's save this. Let's kill it. Let's commit what we have so far. We have list papers. Summary on list papers. Okay. All right. Now let's see. Let's see what else I have on my list of things to do here. A null behavior catcher. I already have that. Prompt editing for reducing total token usage. I think we can do that. Let's come here. Can we make this shorter? I don't even know if we need to make that shorter, to be honest. Seems pretty short to me. GPT text, find papers, summarize papers, palm text. I feel like this find papers should not just be right here randomly. We should move this up here. GPT text, summarize paper, local DB, add paper, list papers, save, get papers. I think maybe we can do like a find paper. Right, this get papers function here. Does this ever get fucking called? Do we even use this? Paper equals db.get papers if paper is none, else. So actually, do you guys want to try a new design pattern? So one thing that I saw on actually Twitter is if we go to Greg Brockman, yesterday he was actually talking about a specific pattern. Yeah, here you go. I have recently started using the walrus operator everywhere in my Python code, which lets you write code like this. If foo bar print foo versus foo equals bar if foo. So why don't we try to do that? You see how we have this same pattern here? Paper equals db.get paper. So let's do this. Paper walrus operator. If paper walrus operator, then we actually do this. We got to flip it. So now we got to have the else statement like this. I don't know. Do you feel like that has more readable or less readable? I guess it's a little bit more readable. Let's see if we find that pattern anywhere else in our code. I use that pattern a lot. The if blank and then do the thing. Here we go. Behavior self behaviors.get. So this is the same pattern here. Let's replace it. So if behavior walrus operator this, is that cleaner? Let's see. Let's run it. Let's make sure it even works. Paperbot has entered the chat. At Paperbot. List the papers. All right, so it actually works. Let's do that. Save, Control Shift G, and we'll do a walrus operator. Can you show the cost incurred in OpenAI? Yeah, let's see. I've currently spent about 0.0048 cent or dollars, so really not that much, but this is important to think about, because I remember we had a channel, or we had a stream where we were using the PDF chatbots, and the PDF chatbots that people make are actually really bad, because basically every time you ask a question, they copy paste the entire fucking PDF into the chat, into the OpenAI. So every time you're using these PDF chatbots, you're basically just absolutely destroying your OpenAI API. You're spending like dollars, you know? So that's something where, going back to our kind of discussion on abstractions, I feel like if you're using LangChain or something like that, you're not even aware of like how many tokens you're actually sending to the OpenAI API, right? Because so many of those are actually hidden from you. There could be this whole like chain of thought situation where there's like 10 back and forths with the LLM that you're not even aware of, and you paid for all 10 of those back and forth chain of thought prompts. So knowing exactly like this is every single piece of text that I'm sending, there's something useful to that. I hate the is not none syntax. Yeah, I mean, we'll see. I don't know. Like sometimes I don't necessarily like kind of more confusing like syntactic sugar. So like this is I would call this syntactic sugar, which is a term for those like little special things like that are used to shorten things. Like I used one earlier, this one here, this one here. This is also a syntactic sugar, the user or blank. But the problem with this is that when you're working in a team, sometimes you're working with like a Java dev or a C++ guy or someone who's like just starting to program. And whenever your code is just like littered with this type of syntactic sugar crap, it makes it so much harder for other people to understand what you're doing, right? So to me, I feel like readability is more important. I think like try to make your code like just simple to understand, not necessarily try to 500 IQ everything into like a one giant list comprehension, you know? But I don't know, that's just me. Okay. Await list papers for embed in sources, share sources. I wonder if this behavior still works. At Paperbot, where can I find more papers? running behavior, share sources. Here are some sources for papers. There you go. Look at that. Nice. We had the weird author info, which used GPT to actually extract. Ooh, actually right here, this is perfect. This is a perfect, author info should take in the temperature. Oh, that's not the one that we want. We want this max tokens temperature LLM. Let's put that there. Because all three of these quargs can be used for this. Whenever we send the GPT text here, we can actually say temperature, max tokens. $100. I asked this because I was testing a simple agent demo and it incurred $2 when I ran the code like 10 times. Yeah, and not only that, but actually a lot of LLM apps that I've seen, they actually, whenever you like ask for something, one trick that I see people doing is that they'll basically call this GPT text or whatever the equivalent in their code base is like 10 times, and then they'll pick the one that is the best. You know, so because this is actually one of the original OpenAI papers where they were doing the code for the leak code problems. I think it was the original Codex paper. That's actually the approach that they use, is they basically would generate 10 solutions and then test all 10 solutions, and then usually at least a couple of those would work. But unbeknownst to you, right, like you just see one final solution, but you don't know that they actually called GPT 10 times and picked the best one out of those 10. So yeah, you got to be careful with sneaky stuff going on in the background. Okay, so one thing that I wanted to do here is I wanted to do a embedding. So let's do this, embedding. And what is the data type for this? So let's go into the OpenAI API. Here we go, API documentation. API reference, this is what we want, and we want embeddings. So get a vector representation of a given input that can be easily consumed by machine learning models and algorithms. So we're going to be giving this the abstract, and then we're going to use that abstract to get the embedding. So here's the response. So the response is going to be a list of floats. Okay, and you can actually determine whether you want a slightly different style. Okay, let's do that. Let's come here, and then we'll say make a new function. We're going to call it define summarize paper. Let's make a function called get embedding. We're going to require the paper, and Copilot wants us to return an np.nd array. Do we though? Do we want that? Do we want to convert it into an nd array? I feel like that's good. I feel like that's fine. I like NumPy. Let's go up here. Let's import NumPy as np, and rather than sitting here and figuring out whether n is before p in the alphabet, you can just save and then come here and do sort imports. Sort imports. No organize imports available. What the fuck? That's not right. Should totally be able to organize that. Okay, let's come here into here. List papers, get paper, add paper, get embedding. Okay, this is the function that we were working on, and we're going to take the paper. Oh shit, look at that. Embedding of type np array equals palm text prompt paper summary. Summarize this app. This is not correct. That's not what we're going to do. We're going to say an embedding, which should be a list of floats, is going to be the result of GPT dot. Actually, is it actually GPT? What's the actual name of the fucking OpenAI API? think it's just, where's the original call? So let's actually look at our original GPT text, and then we'll be able to get it. So it's openai.chatcompletion.create, but for the embedding, it's going to be, what is the Python class for this? Example Python code. This is just counting tokens. Okay, that's kind of pointless. Example Python code. Let's just see if we can get it from the actual VS Code hints here. GPT, OpenAI dot completion embedding, probably this one, dot, and let's actually go into this and see what we want. Create a new embedding for the provided input and parameters. Create class. If in coding format we opaquely use base 64, that's fine. You see they use the same star args, star quargs pattern. Okay, you can actually get it a timeout. They have an asynchronous create. Okay, so OpenAI.embedding, I guess .create, and let's pass in, I don't think documents is the name that you want. We want embeddings, create embeddings. We want model input. Yeah, so it should be like this. Model input. Input should not be should just be paper.summary. Do we want the summary? I think we want the abstract. The abstract is a little bit more fleshed out. Oh, actually, paper.summary is the abstract. All right, my bad. And then model equals, let's do GPT. We're going to have to pass that. Get embedding paper. Let's pass in the model here. Model, this is going to be a string, is going to be default LLM. Actually, you can't really do this because then when you type in Palm, it'll actually just not work. So let's just do GPT 3.5 Turbo, and then we'll do model equals model. And then we'll do that, and then we will return np.ndArray of embedding. And let's put a little breakpoint right here, and we'll call this function here when we're creating this embedding, and this wants to make it a list of float 64-bit floats, but I want a NumPy data type. Do they have a NumPy data type? Maybe just array, I guess. pd.array, that there's no like actual type for that though. That's a little sketchy. Okay. And let's put embedding at the very bottom here so that we can come here to the very bottom and we can say embedding equals get embedding of paper. And let's run this. All right. Paperbot has entered the chat at Paperbot. List the papers. Okay, at Paperbot, and let's add a new paper here. So let's go here, let's grab this paper from Freon here. Let's put that paper there. It's going to run the add received message. Okay, so we need to at Paperbot. Okay, it's getting it. Running behavior add paper. It's running the add paper behavior. Found paper. Permission. You are not allowed to generate embeddings from this model. What? The fuck? What embeddings am I allowed to use? You can use the list models API. What models are available for embeddings? Do you think ChatGPT knows that? What models are available for embeddings in the OpenAI API? I am using Python and calling openai.embeddings.create. Let's put that there. On the topic of only learning at the right level of abstraction, what do you think about the training libraries out there? Do you consider something like guidance-transformers too high level? Yeah, maybe. Like, I also don't like PyTorch Lightning for that same reason. But, you know, like, I have to be honest with myself, right? It's like I can write stuff in TensorFlow and PyTorch and JAX, but realistically, the true abstraction there is actually the CUDA kernel, and I don't actually fucking know what CUDA kernels I'm using, right? So, like, I'm sitting there typing my little fucking PyTorch model, and then, like, underneath that, there's a bunch of CUDA kernels that I really have no idea what they are or even how they're designed. So, you know, I'm sitting at an abstraction layer that isn't great. And maybe that's an example of what I was saying, is that it seems like right now you're seeing this kind of Cambrian explosion of hardware. And because you have this kind of Cambrian explosion of hardware, you're going to have a Cambrian explosion of frameworks on top of that, right? And I could see a world where TensorFlow and PyTorch start to kind of become less and less useful, and you need to kind of have an understanding of like what hardware are you running this on, like, I don't know, and then maybe in that case, like, knowing all the little one weird PyTorch tricks from 10 years ago doesn't even matter. But yeah, CUDA kernels are just like next level shit. Like, you know what I'm saying? It's like, it feels like you have to sacrifice a demon in order to like actually understand them. Okay, so OpenAI embeddings create from pre-trained. This is no good. All right, that's fucking worthless. It's telling us how to embed using the transformers, which is the Hugging Face. Hugging Face, I guess, has GPT-2. It might not even have GPT-2. This might even be hallucination here. And you load the tokenizer, you load the model, you tokenize your text, you load, you put that tokenized text into the model, you get your output, you get basically cut off the head of the GPT-2 model, get the last state, and that's going to be basically the embeddings. But I don't want to be using the Transformers API. I want to use the actual OpenAI API for embeddings, because I thought that they would have embeddings for GPT 3.5, right? Engines? Embeddings? You can use the list models API to use all of the available models. Okay, so can I... Do I have to, like, is there some way to, like, do this in Python? Text DaVinci 003. What if we just use this? Let's try Text DaVinci 003. Let's go into our embedding function. Let's do this. Okay, running Paperbot. Where's Paperbot? There's Paperbot. Howdy, Paperbot. Paperbot, how's it going? Paperbot is my friend. Let's send it this archive paper. Adding or running behavior add paper, which is what we want. Okay, give it a second here. Eventually it'll break point right here once it tries to actually get the embeddings. You are not allowed to generate embeddings from this model. Dude, what the fuck? Come on. Where, like, can I just get a list of the fucking models that work? embedding engine API resource. Engine API resource is from API resource. If I control F for model here, params.get model. Model is engine or model parameter. What about engine? Engine must provide engine. Must provide engine. What if we actually search for the error that we're getting, and then we can get the actual OpenAI permission error. You are not allowed to generate embeddings from this model. Let's actually copy that and search it in Google. Somebody for sure has run into this before. So let's put it in here. OpenAI, when trying to generate embeddings not preventing OpenAI, question answering, I think it might be this. Text embedding ADA002. Okay, I feel like this one, it literally has embedding in the name, so I feel like this one should work. Let's close out of this, close out of that. I was doing embeddings yesterday, but through transformers. Yeah. We could definitely do it through there. I think I already have boilerplate for Hugging Face in here. Yeah, like I literally am already setting the Hugging Face key, so technically we can use transformers, and that'll be more useful too, because then we can embed images too. Like there's models on Hugging Face for images, so you could embed. You could use clip embeddings, right? You could even compare a picture to a text with the clip embedding, so that should be useful. But I want to actually try this OpenAI embeddings API, see what it looks, see, kind of get a feel for it, you know? All right, let's copy this. At Paperbot. Should say running behavior add paper. It did. Okay, it's adding the paper. Now we're coming here. Where's that breakpoint? Come on. Boom. There we go. Okay, so we got it through. So text embedding ADA002. There you go. So actually, here's the tricky part. Let's copy this. Let's copy text embedding ADA002. Let's go into the OpenAI embedding class. So you see that here. It's inside a specific Python library module here, so we can go here. We can do Control-Shift-F, and let's search for the name text embedding ADA002, and let's go here, and let's copy the path for this. I think you have to left-click or something like this. How do you do this? Go up here, and then you say Copy Path, and we'll put that there. And let's limit our search to only this. So OpenAI packages. So we're going to search inside all of the OpenAI packages. Is there any reference to text embedding ADA00? There is not. Okay, so that's important, because what that means is that the OpenAI Python API does not check to see if the string that you're putting in is not available, right? So sometimes Python APIs, before you send the request to the actual OpenAI backend, it'll check. It'll say, okay, is it at least one of these? And then if it isn't, you know, it'll complain right there, and it'll basically error out before it even sends it to the backend. But what this is telling me is that they're not doing any checks on the actual Python side. They're basically sending whatever the fuck you put in here is getting sent over to OpenAI, and then the error is coming from the actual backend side of it. All right, so we're here in embedding. Let me make sure that this is correct. So what is this? Embedding. Here you go. API key, list, blah, blah, blah. Model, embedding 2.0, data. So there should be a key here. Is embedding.embedding. Let's open up the debugger. How do I open up this debugger down here? I like accidentally closed it, and now I don't know how to fucking open it. Maybe this? Yeah, there you go. Debug console. Let's do embedding of embedding. So there's no key called embedding. And that's because the key, here's the actual embedding. You see all these numbers? This is the actual embedding, but let's scroll up. Let's see what it's actually called. Holy shit, that's a lot of numbers. It's called data embedding. Okay, so it's actually like this. It's embedding, data, embedding. Oh my god, it's even worse than that. I think it's embedding data 0 embedding. Dude, what the fuck? That's fucking gross. Why is there... Alright, I guess maybe you can pass it a list of things and then it'll basically create embeddings for all of those and then you would have multiple indices here, but this is a really gross pattern here. So embedding data 0 embedding. Like that. Let's copy this just to make sure. See if it works. Maximum supported dimension for an ND array is 32, found 1536. Is this correct? Can you just do that? I'm pretty sure you can just do that. What's wrong here? Wait, what the fuck? Is this not a list? If we do type of that, it's a list. Okay, so actually we need the 0th float. First time here, what are you building? We're making a little Discord bot. So we have a little Discord bot that basically just like kind of like finds papers, lists papers, and like stores it in a database. Unpacking stuff from OpenAI is full of magic indices. Yeah, this is like really gross. And you know what the worst part of it too is that we're going to leave this code for a month and we're going to come back a month later and all of it's going to break because it's no longer going to be this weird magic indices here. Okay, so the length of this is 1536. The type, let's do a little list comprehension here. Type of X for X in embedding. Float, and let's say all float equals type X for X in embedding. True. Okay, so these are at least all floats. So then why does NumPy not like this? We're using OpenAI API to summarize the abstract, but then right here what we're doing is we're taking the abstract and we're feeding it into OpenAI's embedding API and creating a vector of numbers, which is known as an embedding, and that is a specific point on a manifold in a high dimensional space, and that point should represent kind of the semantic meaning of the abstract. And the reason you can you want these embeddings is because you can then use any kind of distance metric. So you can say how close is this embedding to that embedding, and is it closer or further away to that embedding than this other one. And it's a way of kind of doing a similarity search, so you can find papers that are similar because the embedding of their abstract are close together in this embedding space. So that's ultimately what we're doing here. Normally, you would not be doing this by hand. Normally, you would use a vector database. There's a bunch of different tools specifically for this. I think the one that most people use is called this one, FAISS. It's a vector database. I think there's also other ones now. I think Pinecone DB is another one. So this is a startup that offers you a vector database, and then this is the actual vector database that I guess they open sourced from Meta. But a lot of projects use this FAISS, and some projects use this Pinecone. So that would be the actual way to do this if you actually wanted to make the big boy version of this, but we're just kind of making a little MVP kind of like throwaway version of this. So we're going to be doing the actual embedding and similarity search ourselves. Okay, so right now we're kind of stuck here because NumPy does not like this. It does not like this list of crap that we gave it. I think you can np.ndarray. Is it like from list or something like that? Why does this not? NumPy array from list. np.array. Okay, that's the problem, is that ndarray is a type, not a list. I think we do this. Yeah, okay, that's what we want. np.array.dtype. Let's see what it chooses. So by default, it's going to choose float 64, which I think is what the OpenAI API was saying that they use. Yeah, so if we go to embeddings here, these kind of look like float 64s. Okay, np.array of embedding data 0 embeddings. Okay, so that works fine. Now we have our little embedding here. It's getting stored inside our little database. And now we should be able to basically say, do you guys want to make an octree in embedding space? It's like overkill level 9 million. Similarity search. Look at this. I didn't even have to write that. This is not what I want. This is just the distance between the embedding, and I want the cosine similarity. You can do this? This is fucking crazy. If you can do this, you can just sort based on a mapping function like this. All right, so first of all, the similarity search should actually use a paper object, so it should not use an embedding array. It should basically use this. What else? Do we need this K? I think maybe numpapers. Let's call it that. I think that's a better name for it. Here we do cosine similarity. So you see it made a function for us. It's doing the dot product between x and y divided by the norm of x times the norm of y. I don't feel like that's the right way to do that. Why does it not like this as well? Do not assign a lambda expression. Embedding equals paper dot embedding. You know, why don't we do cosine similarity, and then let's copy this, and let's go into Bard, and And let's say I have a polars data frame which contains a row or a column called embedding. Embedding is a 1,500 long vector or length vector, 1,500 length vector of float 64. I want to create a function that uses a similarity, uses cosine similarity search to find the nearest K papers. The name of the data frame is df.self.df. Can you fill in the rest of this function? And then we're going to give it the function that we have so far. Let's change this back to K. Cosine similarity using paper.embedding. Actually, let's do this. Let's call it embedding, and then we'll say np.nd array, just because I think if we give it the object, the archive object is just going to confuse a little bit. So we'll simplify the actual function for it, and then see what it says. Let's also do it in ChatGPT, and we'll be able to compare the results. All right, so this is the one that Bard gave us. So Bard uses np dot of embedding with self.df embedding.values.transpose. Okay, so this is going to be kind of very expensive because it's literally going to do a dot product with every single paper in the thing. But I don't know, I guess we don't really have a ton of papers. We don't need to necessarily worry about speed for now. I don't know what this arg partition cosine similarity negative k forward. So this is like doing some slicing. And then once you actually get, so here's basically you're getting a NumPy array that has the cosine similarity between the embedding and every single other paper embedding. And then you're using NumPy to actually give you the top K of those. And then you're using the indices of those top K to sort through your data frame. So let's see what ChatGPT said. So ChatGPT, oh, look at that. It's using sklearn, which is a very popular machine learning library in Python, and sklearn has specifically a cosine similarity function here. So first thing that GPT does is it normalizes the embeddings. I'm pretty sure that OpenAI probably returns normalized embeddings, so I don't know if we need to do that. Then it ensures all embeddings in the data frame are also normalized. Okay, then it normalizes the entire data frame. So this is fucking very slow. Then it turns the embeddings column of the data frame into a Python list, and then puts the embedding that we're using into a list, and then uses the sklearn similarity function. And then it does the same kind of thing where it basically uses NumPy to actually sort and get the top K, and then it does the df.take of the top K. So I think this one's actually worse than the Bard one. Let's try the Bard one first. So let's copy that. Let's put it in here. Let's get rid of these comments. I just hate these type of comments like this. I prefer that. We're going to give it the paper. Like that. And then let's say paper embedding here should be paper.embedding. No, actually, this is not what we want. We want this. Embedding equals get embedding of paper. Ooh. Make sure we type this. This is an mp.nd array. Cosine similarity is also going to be an np.nd array, and then top k is also going to be an np.nd array. Let's get rid of this. Let's put a breakpoint right there. Add paper, similarity search, list papers. So how do we want this to actually work? We want maybe a new behavior that's called find similar papers or something like that. Find related or find papers. Yeah, let's do like a find paper behavior. Find a paper or similar papers in the DB. Why is this not liking it? What's going on here? There's no comma. Maybe that's what's going on. There we go. Now we have a comma. It says, okay, well, I don't know what the fuck this find paper function is. And we're like, well, no problem, buddy. We can just tell you what this find paper function is. Let's go up here. We got chat, we got author info, we got share sources, we got list papers. Let's put it right on top of list papers right here. Let's copy paste that. Let's put that in here. We get the message, we get the channel. Let's do find paper. I think that's what we called it, right? Is that what we called it? We called it find paper. Okay. Gets a bunch of quarks. We need to basically do this here. We're going to go to the find paper, get papers here. So the add paper, it's actually going to be similar to this. For paper in find papers, found paper, get short ID. If paper in DB get papers, paper was already posted. So actually, let's copy paste this. For paper in find papers, found paper, the paper was here. If you actually get the paper, then the message is, here is the paper. Found the paper in the DB. If the paper is not found, this is where we actually want to do the find similar papers. So let's go here and do similarity search. Then we'll say db.similarity search of paper. And we'll say similar papers, I guess, or something like that. What is it? What does this return? This returns this here, which is iloc df top 10. So I guess we do look at the list papers. Yield from cf df dot iter rows named equals true. So we actually want to do a similar thing like this. Yield from df dot, I think we're gonna have to do this. And then here, this is going to be a for loop as well. So there's going to be for paper in this. And then we're going to say, here are these similar papers. Fuck. Ah! I fucked with this function. It's no good. Oh my god. Control-Shift-Z? Fuck. Alright, well, we just fucking scrambled that. Let's come here. Actually, one thing you can do if you kind of accidentally deleted things is you can go here and you can see the exact changes. So we don't want to mess with this add paper function, so let's go ahead and put that back in there. Okay, so now you see the only thing that we changed is this, and let's go ahead and re-add our define find paper like this, and this should be an async function. All right, let's close this working tree. Let's come back here. We have the find papers. There's no S. It should just be find paper. Okay, so if you find the paper, you just simply say, I found the paper. If you did not find the paper, then you're going to try to find similar papers. And in order to do that, you're going to basically do this here. For paper dict and db.list. So basically here, you're going to have a message. First thing you're going to say is could not find paper, but looking for similar papers. Could not find paper. Looking for similar papers. You're going to send that message. Then you're going to go and actually go through all of these. You're going to create these embedding objects here. You're going to put this crap in there. These embeds. Unfortunately, the name of that object in the Discord API is also called embeds, which is a little bit unfortunate because it shares a similar name. And then you're going to do that. So similar papers. And then here in the description, let's actually be a little bit more clever about this. Let's say this is going to be an F string. And inside this F string, we're going to say here, list papers, this should be similarity search. Title, URL, summary, similar papers, info message. I think this is pretty much the main chunk of it. Save. Let's format the document just so get a nice little formatting here. Let's actually save this. Similarity search. Add that. Commit. Sync changes. Hey Hoopo, what are you using to store the papers? So I am using literally a not pandas, a polars CSV object. So I'm just reading a CSV object, and then I'm storing it, and then I'm reading that CSV object. So this is not actually a real database. This is literally just a CSV file, but I think for this little mini project, it's totally fine. So we're going to go ahead and delete that. Okay, we're going to put breakpoints here in similarity search. We're going to put breakpoints here in find paper. And let's go ahead. Let's do that. So now let's go into our bot. We're going to run it. Okay, there's an error here. No file path provided for local DB. Creating new local DB at self.filepath. Okay, I think it's because we need a What? How did that change? Oh, you can't use this pd.array object here. Nested list, you need the actual width, fixed size length. Okay, so polars. Obviously, polars is, if you guys haven't, I have a stream on this, but polars is basically a faster NumPy, or not NumPy, a faster pandas, right? Lightning fast data frame library for Python and Rust. But how do you make things faster? Well, one way to make things faster is you need to basically define things very specifically, right? So for example here, if you want to use a polars data type array, you need to tell it exactly what the width of this array is so that it knows exactly how to allocate. This equality checks, blah, blah, blah. Polars data type. Is there an array of float 64s? Ugh. Data type, base types. pl.list of pl.in32.base type. Why don't we do this? Embedding is a pl.list, or pd I guess. pd.list of pd.float64s. Let's try that. Okay, that seemed to work. Let's add some of these behaviors, or add some of this crap here. At paperbot, add paper this. It's running the add paper behavior. Did it error out? Unable to vstack, embedding doesn't match list, null, and float64. Okay, so right here, this get embedding is not returning the right data type. It wants list, null, and float64. Polars, NumPy, column. Let's see. Polars.from NumPy. Dataframe.to NumPy. Polars.from NumPy. PL.from NumPy. Orient dataframe. Polars column from NumPy array. The problem is, like, I think all these examples are, let's see if Bard knows this. Helpy, Bard. You're my only hope. Bard. Reset. Reset. Up here. What is the correct data type, or polars data type, for a polars data frame column? Let's put it here so you guys can see. That has a, or that stores NumPy arrays of type float64. I want to make a chatbot to help long COVID patients with researching the latest papers and stuff, and I was kind of stumped on how to store all the research that has been done. Definitely going to look into CSV. CSV is literally just like a text file, basically, so it's not going to be great, but I would look into some of these other databases that I mentioned. I would look into either VectorDB or FAISS. I think those are more legit. And then if you want to go like full hardcore mode, there's, depending on which cloud service you want to use, whether it's AWS or GCP, each of them has their own kind of like database tools. So those might be better than CSV. I think if you say you are going to use CSV, people are going to ridicule you. I just don't care. So this is making it seem like we can just literally use the float64. Does that even fucking work? Let's give it this paper. Let's see if it tries to add that paper. Running behavior, add paper. Okay. Why did it run the find paper behavior? Oh, shit. Find paper behavior is now the default behavior. You know what? It kind of looks like the add paper and the find paper behavior are more similar than they are different. So why don't we just combine these two? Let's get rid of the find paper versus add paper, and we'll just have one behavior that's called add paper. And then it won't get confused about it anymore. So add paper, similarity search, add paper. Paper was already posted. Let's do this. Found the paper in the DB. Else, and then here's where we actually copy this crap here. Copy that. Adding paper. And then we'll do the actual embedding. So after you add the paper, it'll look for similar papers. Then it'll go do this DB similarity search, similar papers, blah, blah, blah. All right, let's get rid of this find paper then. So kill this. So format, save. Let's put a breakpoint right here. Thanks for the pointers. I don't care about ridicule either. I just want something that can be reliable and accurate when attached to the GPT-3 API. I was already looking to FAISS, and I must just dive deeper into the rabbit hole. Yeah, it really depends on kind of how much you care about scaling. I think that's probably the most important requirement is like, is this something where you're going to try to like put it on some kind of subreddit or something and like have 100 users and then have 1,000 users and then have 10,000 users? Because if that's the case, the CSV is just not going to work at all, you know? And even FAISS, the Facebook one, I don't know if it can handle that amount of stuff, right? So it depends on like how much you care about creating a tool that can scale very easily, or a service that can scale. If you don't care about scaling, then yeah, CSV is like the easiest possible thing. But if you want something that you're going to be selling, I would look into more scalable database solutions. Mm-hmm. The one, so Bigtable. Yeah, so this is the one, whenever I was working at Weights and Biases, which is a machine learning tool, this is actually the one that they used. So this is a really nice one. It's basically like an abstraction over a database that Google provides for you, and it's like super fast. Like, here you go. Enterprise grade database with single digit millisecond latency, limitless scale, and 99.999% availability. So it basically scales as fast as you, or like, obviously you're going to pay them a bunch of money, but you can pretty much guarantee that you're never going to run into database issues if you use Bigtable, or at least you won't run into issues until you start doing some crazy shit. But I'm sure Amazon has an equivalent. Running behavior add paper. Okay, so it ran the behavior add paper. Adding the paper, now it's here. VectorDB. VectorDB is a database that uses embedding vectors as the kind of key. Thanks for taking the time, dude. No problem, man. Thanks for joining the stream. I feel like for these coding streams, I'm just trying to be a little bit more casual, you know? Like, definitely feel free to ask questions, distract me. Okay, we're going here. Sending that message. Okay, now we're going to go into the db.similarity search. We're going into that function. Similarity search missing one required positional argument paper. Okay, so I think these need to be like this. Over here in similarity search, we need to add the actual paper object. So where is the paper? This one? Is this the paper object? Yes, I think that's the paper object. Put that in there. Kill this, rerun it. Paperbot has entered the chat. Let's take this at Paperbot. Adding the paper. It's going to hit that breakpoint. Too many rows returned. Returned 1,536 rows. Okay, so you see the problem, what happened here is that whenever we added the paper, right, you see we created this column called embedding, and then we made it a PD float 64. The problem is that whenever we created this data frame here, all of these were of length 1, but then we gave it a vector here of length 264 or whatever, 1,500 something, right? Which is the size of the embedding. So whenever we called this VStack, what Polars ended up doing is it ended up creating like 1,500 whatever rows of this. So that is not what we wanted, which means that this actually is still the issue, is this PD float 64. PD dot list. Can we just do this? Let's delete this. paper bot. Running the add paper behavior. All right, it's going. Is it stuck on anything? What's it stuck on? I think it's waiting because it's summarizing and then creating the embeddings for that. There's like 3 different OpenAI calls here whenever you actually add a paper. It has to summarize the paper. It has to get the embedding of the paper. OpenAI rate limit error. That model is currently overloaded with other requests. Fuck. Are we dead? Is the stream dead? I think we, if the OpenAI API doesn't work anymore, we might be out of luck because there's no way to actually. Let's see. Oh, dude, this is such a fucking issue. All right, we're going to do something very, very hacky here, guys. Here's what we're going to do. We're going to change this. We're not going to make embedding a list type. We're going to make it a UTF-8 type. And then whenever we get the embedding, rather than returning this, we're going to do something absolutely heinous. And here's what we're going to do. We're going to say, comma, dot join of string of x for x in embedding. So we're literally turning a list of float 64s into a list of strings, and then we're taking that list of strings and we're joining it with a comma. So it's this giant comma separated list of list of float 64s. That's how we're going to be storing it in our database, which is fucking gross, but at least we're not going to get these fucking weird polars like v-stacking errors. So that means that whenever you do this, this is just going to be a string. That means that when you get the embedding here, it's just going to be a string. So in order to, this is going to be embedding string equals get embedding, and then embedding is going to be this. Right, so you're going to split the embedding string by the commas. You're going to convert each of them to floats, and that's how you get your embedding. So that is very gross, very inefficient. I would not recommend that, but you know, we gotta eat. We gotta get going. We gotta actually get some progress here. So let's just do that. See what happens. Let's run it. Let's go here. Paperbot has entered the chat at Paperbot. Give it this. Put that there. Style drop. Running the behavior add paper. All right. So it added the paper. Now we step through here. It's creating this similarity search. Let's go in. Boom. All right, so embedding string, this is that very long string. Look at that. Oh my God, dude, this is so gross. Look at that. It's just a giant string. All right. So we're going to hit next here. Did it at least work? It did work. Look at that. You have a giant float 64 string. And For those of you that are paying attention, we actually are storing it twice because this local variable here, embedding us underscore str, still exists. So within the function scope here of similarity search, not only do we have the giant float64 vector here, but we also are still in memory keeping this embedding string. So it's doubly bad. All right, then we're going to do the actual meat of it here, which is multiplying. This is going to be an issue too, because now we need to convert this as well. Holy shit. I don't know. I don't know if I can do this anymore. Because the problem is that this entire data frame, all of the embedding values in here are, they're now strings. So we would need to convert every single one of these into a... I think there's something hacky we can do as well. We can create this as a lambda function, and then we can map all of the embeddings with that lambda function. Like if we do df embeddings, yeah, like this. So, yeah, there you go. This is gross. This is so gross. Let's see. Let's at least step through this so we don't have to error out. So df embeddings, okay. Let's do embeddings. Okay. Let's do cosine similarity here. That should work. What is cosine sim? It should be a single number. Yep. It isn't perfect, which is weird, right? It should actually just be 1 because this is the exact same vector, but there's probably some random little floating point error there when it's actually doing this float of x or something, or maybe when it does the NP array here, it actually converts it in a weird way. Let's see if this part actually works here. Top k index. Out of bound k, let's just make it a 1 for now. And then let's try that. Okay, and what is top k index? Top k index should be a list of indices. And I don't know if iloc exists in polars. I think it's a different thing. Yeah, what is the equivalent of iloc? I think maybe just this. Yeah, I think you just do that. Okay. So let's close out of that. Let's do this. And it'll say yield, and this yield means that it'll give us the most similar papers, and DB similarity search, similar paper. 1 second. I kind of have to sneeze. Ugh. All right, it'll return all the similar papers sorted based on the similarity search. And there you go, similar papers, log info, it'll send that. Okay, Let's run it. Let's get rid of some of these breakpoints. You should not. This is probably the grossest similarity search you've ever seen. So definitely do not use this. I'm doing a bunch of really, really slow, like float to string to float to string to float going things here. So do not use that. Okay, we're running this. Paperbot has entered the chat. Let's give it this paper. At Paperbot. Boom. All right. Running the behavior. The paper was already posted. Okay. Now let's do, what about one of these other papers? Let's find another paper. Scroll up until we find a paper that we haven't put in there. Let's do this one. At Paperbot. Running behavior add paper. Okay, it's got a lot of things to do. It's got to summarize it. There's like 10 different OpenAI calls here, so maybe we get a rate limit error. And while that's chewing on that, let's find a different paper. Let's do this one here. Brainformer. So as you go into papers, let's find one that it hasn't found before. This one here, reconstructing the mind's eye. Yeah, we hit the rate limit error. Oh no. Oh no. All right, we gotta wait like 5 seconds for the API to chill out. There should be 2 rows in here. Here's your giant gross ass column there. Okay, do you think we've waited enough time? Let's do it again. Let's put this one, and then let's also looking for similar papers. Okay, that's fine. Let's get rid of these breakpoints and let's keep going. Similar papers, 1 total. And here's the similar paper. Okay, so now when we add this other paper here, it should be more similar to one than the other. There you go. Okay, so it decided that this paper is more similar to this paper than it is to this paper. Let's see if that's true. That is 100% true. It found the segment anything paper, and it said the segment anything paper is more similar to the segment anything paper than it is the reconstructing the mind's eye paper, which makes sense because it's literally the same fucking paper. Okay, but this works, right? What will we do next? Next thing we would do is basically make sure the similarity search should not return the paper itself. So you would have to basically find the ID of the paper and then get rid of the ID of the paper. Maybe we could print the actual similarity so you have an idea of how many, whether or not it's very similar or just kind of similar. Maybe we would filter, we would make sure that it knows how many papers already exist in the database and give us X amount of papers and then make it format it nicely. But the stream is already almost 3 hours, so I'm going to end it there. Let's commit what we have. Let's say similarity search in the worst way possible. And let's commit that. All right. So maybe a quick summary. Boo, come over here. Come over. Can you guys hear her? Boo, you have anything to say? Come over here. Boo. Boo is the cat that appears on all the marketing material for this channel. Boo. She really likes to meow. Very vocal cat. Okay. So, little summary of what we did. I think we were working on this Discord bot. This is just a little bot that goes around and uses the archive API and as well as the OpenAI API in order to summarize papers. I think kind of the cool part of this bot is that the behaviors that it chooses are based on the LLM. So it's kind of like a tool former kind of thing where the LLM itself is choosing which function to call, right? So there's a couple different functions here. You can chat with the LLM, you can add a paper, you can list the papers, you can find more information about a specific author, or you can share links for finding papers. And we added some functionality to the add paper where basically it does similarity search with already existing papers in the database using cosine similarity. But we ended up having an issue where the Polars data frame, which is our fake database that we're using, has kind of weird requirements around the data types, and it's not entirely clear how to put a NumPy array or some kind of like float64 array into a column. It wanted to separate it out into different columns. So we ended up creating this very hacky workaround where we turn the embedding into a string and then store it like that. And the embedding that we're using is coming from the OpenAI embeddings API, which basically you can say openai.embedding.create, and then you choose the actual model you want to use to embed it, and that gives you the actual embedding. So those are a couple of the different things we did. Hope that was entertaining. Hope that was cool. If you have any other suggestions on what we can do in terms of programming projects or things you want to do with this bot, let me know. If there's any other papers that you want, also let me know. I don't have anything specifically lined up for tomorrow, but probably going to be a paper reading. And yeah, thank you for listening. Thank you for chatting, and talk to you guys.